The motor actually fits right in the end of the PVC pipe. So, so that was the first turbine that was built. And what's elegant about this tower is that as the wind blows harder, the PVC pipe bends, and the turbine then kind of tilts back, and so you have the blades start to tilt back like a helicopter, and then it's an overspeed protection. And every wind turbine needs to have some type of overspeed protection, either tips in the blades or pitching, full pitching mechanism, which gets a lot more complicated. Actually these little propeller blades are stall regulated so that they get to a certain speed and they start to stall. And that's the ideal, is to have the power curve get kind of flatten out as the wind speed increases, so you don't overproduce and get into a unstable overspeeding situation. So this is a finished wind turbine blade. Actually, this has been a demo for a long time, and what I did was just urethaned it. Now this blade is made out of red cedar, which does grow. I think it grows in the northeast. But I wasn't able to get any red cedar this time for the latest batch. But anyway, urethane, good high quality urethane will protect the blade from weather and also erosion, because the leading edge of the blade actually sees if there's any dirt in the air, dust or dirt, it'll actually erode the leading edge of the blade. In fact, back in the 30s, when there were 1 million wind electrics throughout the Midwest and the U.S., mostly the Midwest, but they were here in Western New York too, before the rural electrification, they would use sheets of brass, copper. Actually, copper sheets would be attached to the leading edge of the blades in the old wind chargers and Paris Duns and Jacobs. And so other things that I've used for finish is Rust-Oleum urethane paint. But I like the urethane because the sunlight is protected. The urethane doesn't break down in sunlight, and it's a nice shiny finish. You can sand it and put more urethane on and get it really shiny. And the idea is you don't want the blades to get dirty, because that causes roughness, which causes turbulence and loss of power. So you want the blades to stay as clean as possible, and that's it. Wind turbine actually is a hands-on type of thing. To own a wind turbine is a hands-on type of thing. With photovoltaics, you can just, once you get it installed, you can kind of walk away and forget about it, although you need to maintain your batteries if you have a battery, off-grid battery system. With a wind turbine, actually another thing that is important is that a wind turbine constantly needs to have a load on the generator. So that means that you have to have, the generator needs to be connected to a battery to provide the resistance to the rotor. Otherwise, if there's no load on the rotor, it can run away, and could be catastrophic failure. So there's charge controllers that are available, and now we're getting more sophisticated, but there are charge controllers that are specially made for wind turbines. And when your battery gets fully charged, then the load is transferred to a resistance, something that's heating water or air. So you can heat your house, the air in your house, with a resistance bank or a electrode that fits in a water tank. So those are two different ways of controlling a wind turbine's charging of a battery system. If you have a grid interface inverter, which you can hook wind turbines up to, special made wind turbine inverters, grid intertie inverters. Then you can be just dumping the power into the power company's grid, and you can be offsetting your energy use without a battery bank. So there's a lot of different options. You can do grid intertie and battery backup. It just depends on what your preferences are. A lot of us feel that these are survival tools, and we want them to be off-grid. And we actually, there's different battery systems that you can get. You can get used forklift batteries, are a good type of battery bank. And the batteries need to be taken care of. You need to keep them clean so that you don't have any discharging from tracking from post to post on the battery. They need to be kept warm. Lead acid batteries lose their performance when they get cold. So it's good to have a heated battery, and also ventilated, well ventilated, because these wind turbines and solar panels are, when they're charging batteries, they create hydrogen gas, which you want to be able to have it vent outside or away from flammable open flames. Anyway, thank you.
Okay, Barry was talking about a way to divert load after your batteries are charged, and that requires a thing called a shunt regulator. And what we're looking at right here is a schematic for a shunt regulator. Here's the parts list that go with it. You can pause that and try to read it. And there is the schematic. Now this comes from the book, and we'll turn it over here. How to Build a Wind Turbine.
Hugh Piggott.
Hugh Piggott. This is 2005 edition, and that was available from Lindsay's Publishing. And where's that website? It's LINDSAYBKS.com.
Just dumb everybody down, make us so ineffectual that we have no self-confidence whatsoever to do anything at all other than what somebody tells us to do. And you know, what a shame. Here's an old water heater that was thrown out, and I couldn't stand to see material that is useful for something else, you know. And so, and it cuts with this pair of tin snips, and this will be the tail of the turbine. So here's what I was thinking of doing with the car bodies is, you know, here are all these doors and windows, you know, and window cranks and stuff. And so you could take these cars and just cut them into pieces and then make a dome out of them. You know, make triangular shaped pieces out of the roof, and then you can have the doors and windows be part of the dome, and then just spot weld the whole thing together. Just spot weld it all together. And then you could stucco it, or you could insulate, foam it. You could shoot it with foam.
Like a geodesic?
Yeah. And then you could bury it. Buried underground. You know, you could flip it upside down. You know, it would be the mold for a gunite. You could make it out of clay, you know, reinforced clay or cob, and structurally put this thing together. And hey, the sky's the limit, you know. But we want, this is really all that's left of finishing this turbine is the tail, because everything else has been done. But because it's already been started. Ta-da! There's a tail. It'll have to be painted. And then we get a piece of PVC pipe and see how long it is. And it is. Hey, look at that. Just the right length. The plate is 14 inches, so here's all I need to do is mark off maybe 14 and a half. Maybe I better use this pen right here. And 14, yeah, 14 and a half. So then we put it in the vise, and a vise is really a treat. And actually what we have here right now, and oh, I just realized I have my wife's measuring tape. We're going to cut this one in half. And it's 35, so we're going to cut it at 17. And it's really nice sawing PVC pipe. And you know, you can make wind turbine blades. Sandy had a really great, did you see the plans there for a wind turbine with PVC for the blades? And you cut them a certain way, and you look at angle and everything automatically. I mean, you know, these are Cadillac wind turbine blades that we're making here. They're really, there's the bottom piece that goes right there. And this one then will be for another turbine. And this one will be down. And so then we just cut a slot right in the middle. And make sure it's in the center. So you just kind of eyeball it and get it started. Great exercise. He needs to go to a gym. That's about half and half. What I did was I took a 2-inch pipe nipple and I sliced it in two, so that I had one for another turbine. So I got two of these pieces out of one pipe nipple. I just cut it with a hacksaw. And then I just spot welded it onto this little plate.
Can you point to the nipple?
Pardon?
Can you point to the nipple for us?
This right here.
Great.
Is a 2-inch pipe nipple. NPT, Whoa. National Pipe Thread. And so then I just have this adapter to 2-inch PVC, which is just a, that fitting right there. Male adapter to the 2-inch NPT. So, you know, we can glue this together. So this will be the tail extending out here, and this will be the part of the part that goes over the tower. 2-inch NPT, and then we'll go over a 1.5-inch pipe, PVC pipe. And so then it'll rotate. Tail will come out here, blade will be here, and as the wind blows harder, the PVC tower, the 1.5-inch tower, will flex, causing the rotor blade to spill the load. So it's like a natural governor.
Oh, that's looking much better than mine.
And what kind of motor is that?
And this is a, it's actually got a Kodak written on it, and Kodak Hathaway. So it is just a 12-volt permanent magnet DC motor. And it was probably ran a copy machine, because it's got a pulley on here with a, used probably a rubber a cord type of belt drive. So it was probably mounted inside of a printer copy machine. And but they were surplus center in Lincoln, Nebraska. Great supply house of surplus and motors, hydraulics. So anyway, you've got 12 volts coming out, and we've got a diode.
And now the motor, when it's spun, becomes a generator, correct?
The motor becomes a generator. The diode allows the current only to flow down the tower and into the batteries. The battery power won't go back into the generator and motor, which is what it would do without the diode. And that's a pretty beefy little diode. It'll handle certainly a lot more than 50 watts of current. So what we actually did was we drilled and tapped 1032 threads in the pulley in such a way that and actually I had these washers for the plate on the nose on the front of the turbine, and so then 1032 stainless screws hold the blade onto the hub, and there's a little set screw actually in the hub that holds the hub onto the generator shaft or motor shaft, the little set screw. So anyway, I mean, it's a ready-made wind turbine hub, this little pulley. This little turbine really is not going to generate a whole lot of power, 50 watts of power, but if you have a windy site, and actually its duration that the wind is blowing is really the amount of electricity that you're going to generate. This thing will probably start charging in maybe a 7 mile per hour wind. The formula for extracting energy from the wind is 1/2 the air density times the velocity of the wind to the third cubed times 1/2 rho A, the area of the blade, 1/2 rho AV cubed. So 1/2 the air times the air density times the area of the blade times the wind speed to the third. And so anyway, but you could run a car stereo, you could run some RV type lighting, which is very efficient fluorescent. There's a lot of 12 volt appliances available. The other thing is that you could charge at 24 volts, but then your rotor speed would be twice the speed. And at 12 volts, the rotor speed is just the optimum speed for the output of the machine and the size of the blade. And all three are variables that you want to, they're all three kind of go together in the design of a wind turbine. The speed of the generator, the area of the blade, plus the capacity of the generator, or how much current it can produce or consume if it is a motor that is being oversped to generate electricity. It's in the simplicity and the importance of a direct drive, no gearbox. You want the generator to be the optimum speed for the rotor diameter, the size of the blade. So a treadmill motor, which turns at a much slower speed than this motor, which as the rotor gets bigger, the speed of the rotor needs to go down. The optimum tip speed is about 150 miles an hour. So that's another criteria for the design, is you want to have the tip speed around 500 or 150 to 160 miles per hour. The secret is to have a balanced wind turbine blade, and this one we can see is definitely out of balance. Without even trying, this blade is going to drop down, and so what we have to do is just keep machining material off of this blade until it balances out. And it needs to be, with a two-bladed machine, you really need to have it perfectly balanced. If you have a three-bladed machine, you can have each blade a little bit out of balance, and it's not going to shake the machine apart. But with a two-bladed machine, it's of utmost importance. Otherwise, you're going to have a dithering effect where it's, as the heavy blade comes down, it's going to shake the tower. It's going to cause the thing to yaw back and forth. That's pretty flat. It'll straighten out. So then we just put this guy, and I don't know which side to put in there. There we go. And put it together like down there and down here. And and it's not bad right there. And a drill, and probably right there. Good pilot hole, that looks good enough. There's one. There's a pilot hole. And let's see, I've got whoops, that's not going to work. That might work. Pilot holes are always good to do, you know, because they make it easier to drill the next hole. Now, I think a 1/4-inch bolt, and we need to figure out, they're made to go on there, and enough room for a jam nut as well. And so, boom, boom, boom. And let's put a jam nut on there. Boom, boom. And we'll save the other one for the other jam nut, which is really a jam nut. And voila, we'll tighten them up. And it's ready to be painted, which with whatever logo somebody might want on there. And the other thing is, I've done this as a demo thing, but this can be glued to the vertical part of the turbine, which is, oh, we already put it away, but right, this is a similar model right here. And what I did was I drilled holes right here to put nails in here so that you can take it apart if you wish to travel with it, because you could set this up at your campsite if you really wanted to. That whole little tower would fit in a large backpack, and it's only PVC pipe. So anyway, well, yeah, you want the tail to be down, and then this orients the turbine into the wind. And here's a set of slip rings. We already got the slip rings, didn't we? Mm-hmm. And but here's the set of slip rings that will transfer the current without twisting the cables. If you have a wind sight...
Actually, I don't think we went over those, no.
Oh yeah, this was earlier. And so this will be attached to the turbine and rotate with the turbine. This is attached to the tower. And so the electricity gets transmitted down the tower through slip rings. And this is a 3-phase one, so you know we could have one of those 3-phase windings up there. And you know, with the ground, the tower being the ground, there you go. Boom, boom. Nice brass slip rings. Here's the base of the turbine, the base of the tower, and that's going to be, all of this needs to be glued together, but we're assembling it right here. So now what you do is put this on an 1.5-inch piece of PVC pipe, and it fits right up in here and sets right here. So you have a good yaw bearing, okay? And it's going to just yaw back and forth. Just, you know, elegant. And here's the tail. And the tail goes on like this. And you can glue this, or you can drill holes and pin it with a nail. But whatever the case, there is a completed turbine. We do need to balance the blade a little bit more, but this was done pretty much today, other than the blade carving. But hey, I got one started right there that take about an hour to make a blade. When we get right down to it, when we're cooking, 1 hour. So this is the wind turbine workshop right here, and this little motor is a 12-volt DC motor, and when it motors, it's just the right speed to be generating electricity. And
And where do those slip rings go?
Pardon?
Let's look at the slip rings. Where do they fit in?
Oh, the slip rings. Well, the slip rings would be mounted, let's see, they'd be mounted inside a piece of pipe. Inside, they'd be mounted up here, all right, up on top. And it'd be like a window I'd cut out of a piece of pipe for this to access. So this would be inside the pipe, just inside this piece of 2.5 inch pipe. And a window cut out for the brushes to fit in. And then this would be attached. And then the tower would be attached to that piece of pipe to go on down. So, and this would be attached to the tower itself, which would be either there'd be like a tower top assembly, basically, that this would be a part of. And then you'd have a pipe down below for the rest of the tower. So it'd be just maybe square tubing. This piece right here would be welded onto a square tubing with another pipe nipple on the other side. You know, all different opportunities of manufacturing. But as the slip rings get as the turbine gets more complicated, you know, there's different tasks involved. However, what you can do is just have a plug on the cable that goes down the tower. And you could, when the cable starts to twist up, you can unplug it and unwind the cable and replug it. And that's what we did with 50 wind turbines in the Altamont Pass in California. The wind was pretty much out of the same direction almost all the time. And so we didn't have a problem with the free yaw machines twisting their cables up. So, but anyway, this is a prototype wind turbine that actually will make electricity, will actually charge batteries, and probably maximum output is 50 watts at 12 volts. So, you know, right around a little over 2 amps worth of output. And this is made out of a recycled water heater, just cut with tin snips, drill the holes, and the rest is PVC pipe, 2-inch PVC pipe. This is a pipe nipple, a 2-inch PVC, 2-inch NPT pipe nipple that was cut in half and then welded onto the plate from the surplus center generator. And then this is just a adapter from 2.5 inch NPT female to 2-inch male PVC pipe. And you could buy all this stuff at Home Depot. Well, this comes from Surplus Center. This comes from Pennsylvania Hardwoods in Olean, New York. And this came from a recycled water heater. So the secret is Surplus Center, and one of the really beautiful motors is a treadmill motor, and they're increasing in popularity to where people are figuring out that you can make a very nice wind turbine from a treadmill motor. The basics of a treadmill motor is that it is a DC motor, direct current motor, and it's permanent magnets. And so it's very efficient, and the reason it is found in a treadmill is that you can vary the speed of the treadmill with the DC motor and simple electronic controls. So, however, the treadmill motor is the right RPMs. The voltage it's 110 volts or 120 volts DC. So if you use it in a 12-volt system, your rotor speed is 1/10 of what the nameplate speed is. In this case, they're 4,500 RPMs, and 1/10 of that is 450 RPMs, which is an ideal speed for a wind turbine of that size. The size of the rotor would be anywhere from 9 to 12 feet for a 1 kilowatt machine. And so here's the motor. Here's the motor right here. It has a really beefy flywheel on the front, which makes for an excellent hub. And all you would need to do if you wanted to make a 3-bladed machine, you would drill and tap a couple holes here, a couple here, and a couple here, and then you could attach a plate that would sandwich the blades to the hub. Personally, I like a 2-bladed machine, so I would get a piece of wood, probably a maybe 2x8 piece of cedar of cypress, and bore a hole in the center, and then have a blade that could generate probably a reasonable supply of electricity for a good-sized cabin, 1,000 square foot cabin. Anyway, get your treadmill motors while you can. They're still available on eBay, but the competition is getting more stiff. And so anyway, now you can get one for $35 plus shipping, and that might not last too long. So thank you all.
Thanks, Barry.
You could actually mass produce these things. There's $200 is the cost of this thing, and most of it's in the copper. Over half of it's the cost of the copper. So what's elegant about this design is that this is flashing that is pre-bent. Just I use a little jig, piece of plywood, a few pieces of plywood.
And this is a water heater, right?
And this is a solar hot water collector, right? Water heater. So you'd circulate a glycol solution through this, and you would have a tank in the basement of your house that could be made out of insulation framework, 2x4 framework, and like a PVC type of containment to make a tank, a waterproof tank. The material they use to make artificial lakes, you can weld that stuff together and make a watertight compartment. The absorber plate is the flashing, and then it's just stapled to the luan, and it holds tight to the copper tube, so the heat transfer from the absorber plate into the copper tube and into the glycol solution. So it's very efficient, it's easy to build. We're trying to promote renewable energy, and really the solar hot water heater is the most rapid payback and simplest system to be working towards. There's no reason that we can't all be having solar hot water. In 1900, in Pasadena, California, half the houses had solar water heaters. So it isn't like this is new technology. It's not exotic. It's not high tech, and it's available to the masses. And if we have any government at all, that would be what the government would be useful for, is to help promote technology for the masses. Thank you.
Barry, how does this work in the wintertime?
This will work fine in the wintertime, in that actually this is sitting on its side right now, and the glazing material is corrugated, so as once this thing starts to warm up, once a little bit of sunlight starts to hit on the absorber plates, you're going to get enough thermal action to melt the snow and it'll slide right off your collector. And especially in the wintertime, and these can be adjusted easily for summer and winter. In the wintertime, you're going to have a more of a vertical angle anyway, so the snow is going to slide off. And you're using a glycol mixture in here that isn't going to freeze. So and therefore you'll have a circulating pump. So that's how it'll work fine in the winter. Absolutely.
And plenty of heat comes off it?
plenty of heat. And actually, the sun has 1,000 watts per square meter. So, I mean, we're looking at a little over a square meter right here. So there's, you know, say 1,200 watts of energy going straight into the water. And this is probably this isn't the most efficient method of heating water. The vacuum evacuated tubes are more efficient, but the cost-wise, these are $200 versus $5,000 for the same collector surface. So, you know, the way this can be made out of recycled 2x4s. I mean, you know, recycled copper tubing. You know, really the glazing is the only thing that you really would have to purchase, and some insulation. But to me, it's simple, and there's elegance and simplicity.
And